1.2 Solving multi-step equations. When solving multi-step equations, to solve a multi-step equation, simplify each side of the equation if necessary, okay? So simplify here, we're going to be, if necessary, combine I like terms, okay? That's if necessary, I like terms. Think about it, making your expressions smaller, okay, and easier to work with, okay? Then we'll use the inverse operation to isolate the variable. So isolate is what we're solving, okay? Think about what we're solving. Who are we looking for the solution, okay? Who are we solving for? So for example, in combining alike terms, if I have 5x plus 2 plus 3x, the alike terms in here are going to be 5x and 3x. If I was to combine this, I'm going to have 8x plus 2. So as you can see, we simplify it by combining the alike terms to just help in the multi-step equations. So now what if we have 5? Let me use another color. What if we have 5 plus 3x plus 5? If we look here, the two alike terms are this 5 and the other 5. So if we combine them together, you always try to have your variables first, okay? Your variables first. In this case, we have 3x plus 10 when we combine the 5 plus 5. These are just examples. We'll see some more on the next slides. Solving a two-step equation, okay? So that means two-step equation. Solve 2.5x minus 13 equals 2. Check for solutions. So first we're going to write our equation. 2.5x minus 13 equals 2. Then this is a subtraction, okay? So we're going to undo the subtraction by the inverse, which is adding 13 to both sides. I'm not touching yet my x, okay? So this cancels out and I'm left with 2.5x equals 15. I simplified. Now I'm going to see that I'm going to undo this multiplication, okay, with this 2.5x by the inverse, which is division, correct? So I'm going to divide by 2.5 and x equals 15 divided by 2.5. Okay, if I move my decimal, this is my imaginary decimal here, and I'm left with 25 whole numbers. So how many groups can I make in 150 of 25? I'm going to think of your quarters. In this case, 6. Okay, 6 times 150 gives me, 6 times 25 gives me 150. Subtract. So that means that x equals 6. Okay, that's the solution. Let's double check it. Substitute. So we have 2.5 times 6 minus 13 equals 2. So multiply 2.5 times 6, 30, 12, 15. I have only one decimal. So this here is 15 minus 13 equals 2. And 15 minus 13 is 2 equals 2. So our solution is correct. Combining like terms to solve an equation. So first thing we're going to do is write the equation. Negative 12 equals 9x minus 6x plus 15. Okay, so here we're going to combine the alike terms. And the alike terms here are going to be 9x minus 6x. So we're going to have negative 12 equals 9x minus 6x gives us 3x plus 15. Once we're here, we're going to do this addition, okay, this addition here by subtraction of 15. This cancels out and we left with 3x. Negative 12 minus 15, okay? Negative 12 minus 15. Remember what I said? Add a plus sign so that you can see that when you add a negative and negative, you're still going to get negative. And 12 plus 15 gives us 27. If I was to divide this, now we have simplified it. We're going to undo this multiplication by dividing by 3 on both sides. So x equals 27. Negative 27 divided by 3 gives us negative 9. So that's our solution. Let's check it by substituting. So we have negative 12 equals 9 times, our x is negative 9 minus 6 times negative 9 plus 15. So I have negative 12. 9 times negative 9 gives us negative 81. And a negative 6 times negative 9 gives us positive 54 plus 15. So now here we could combine. I like to combine these two first together so it looks easier. So we have negative 81. 54 plus 15 will give us 69. Okay, bring down the negative 12, and now we have a negative 81. Our aim is for negative 12. So I have negative 81 plus 69. So I know that the 81 is bigger, so my answer is going to be negative. So 81 minus 69. Borrow. 11 minus 9 gives us 2. Simplify that 8, which is 7 minus 6 gives us 12. So our answer is correct. Using structure to solve a multi-step equation, example 3. So we're going to solve this, okay? I'm going to give you two methods. So method 1, let me write down method 1. So in method 1, we're going to use the distributive property. Okay, let me divide this over here. So we're going to first write the equation, okay? So it's going to be 2, parentheses 1, minus x plus 3 equals negative 8. Now we're going to distribute that 2 to the 1 and to the negative x. So if we do this, we're going to have 2 times 1 and 2 times negative x, which gives us 2 minus 2x plus 3 equals negative 8. Now we're going to combine the alike terms. And the alike terms here are the 2 and the plus 3. Always take the number in front, not behind. Notice that this first 2 here is going to be positive. Not behind. The behind belongs, that negative sign belongs to the negative 2x. Now the 3, the number in front of it's a plus. Okay, so think of it being positive 3. So if we combine these two terms, we're going to have negative 2x. 2 plus 3 gives us plus 5 equals negative 8. Now we're going to undo that positive 5 by subtracting 5 on both sides, correct? If we subtract 5 on both sides, this one cancels out and we're left with negative 2x equals negative 8 plus negative 5, which gives us a negative and negative adding gives us negative, and 8 plus 5 gives us 13. If I was to divide this, because now we're going to divide it because we're going to undo this multiplication, we're going to divide by negative 2. So x equals negative 13 over 2, or x equals 6.5. And that's going to be our answer. Okay? Checking this solution, all I'm going to do is substitute. So I'm going to have 2. Let me write it in another color so we can see it. We're checking over here. Okay? And I have 2. 1 minus 6.5 plus 3 equals negative 8. So 2 times 1 minus 6.5 is going to give me negative 5.5 plus 3 equals negative 8. And I know that 2 times negative 5.5 is going to give me negative 11 plus 3 equals negative 8. And negative 11 plus 3 will give me negative 8. Let me write it here in black so we can see it. I'm going to have negative 8 equals negative 8. So our answer is correct. Let's go to method 2. Okay. Method 2 is going to be where we have another way to solve the equation by interpreting the expression y. Okay, this is the expression 1 minus x, okay, as a single quantity. Okay, this is where we're going to solve for. So we first write the equation, which is 1 minus x plus 3 equals negative 8. So the first thing we're going to do is to undo that addition. And undoing the addition, we're going to subtract 3 from both sides, which we're left with 2 times 1 minus x equals, because this cancels out, negative 8 minus 3, which is negative 8 plus negative 3. We are going to have negative 11, correct? Now, after we simplified, we're going to divide each side by 2, okay? To get rid of this, remember, a number in front of a parentheses, not with no operation in front of it, just a number in front of the parentheses, means multiplication. So in order to get rid of this multiplication, which is next to each other, okay, next to each other, right here, we're going to divide. And by dividing, we're going to divide by 2 on both sides. And we're left with 1 minus x equals negative 11 divided by 2 gives me negative 5.5 after simplification. So now to leave x on itself, we're going to subtract 1 from both sides. This cancels out and we're left with negative x equals negative 6.5, okay? And remember, you can never leave a variable as a solution with a negative sign. So you're going to divide by negative 1. Or just do the opposite of whatever, and x equals 6.5. And we already had checked this, so we know that our answer is correct. Okay, so which is the same solution obtained in method 1, okay? Always remember we cannot have a negative x. So the best thing to do is either to divide by negative 1 or do the opposite, which we know that the opposite of negative x will be positive, and the opposite of negative 6.5 will be positive 6.5. Okay, modeling with mathematics. Use the table to find the number of miles, x, you need to bike on Friday so that the mean number of miles biked per day is 5. So remember with this is we're going to understand the problem. You know how many miles you biked on Monday through Thursday, correct? We already know this. I put the solution there so you can see it. We already know what we biked Monday through Thursday. You're asked to find a number of miles you need to bike on Friday, okay? So this is x. So that the mean number of miles biked per day stays at 5. So we've been given the mean, okay? Let's make a plan, okay? We're going to use the definition of mean. So what's the definition of mean? It's the average. Normally that means you add all your data and divide by the amount of data you added with, okay? So in this case, let's solve the problem. The mean of the data set is the sum of the data divided by the number, correct? So here we have Monday 3.5 plus Tuesday 5.5 plus Wednesday's 0 plus Thursday 5 plus Friday, which is X, correct? So we write the equation. We are going to divide by a total of 5 equals 5. What is 5? This 5 right here represents the mean. It was given to us. Per day is 5. They want to keep the 5, so we've been given the answer. We're honestly solving for X. And remember, 5 is the total amount of days, in this case, Monday, Tuesday, Wednesday, Thursday, and Friday. Okay, so we're going to combine the alike terms. So in these terms, we have 3.5 plus 5.5 gives us 9. 9 plus 0 is 9. And 9 plus 5 gives us 14. We cannot add that X, so it's going to be 14 plus X divided by 5 equals 5, correct? Now we're going to undo this fraction by multiplying each side by 5. This cancels out and we left with 14 plus X equals 25. We're going to undo that addition by subtraction, so we're going to subtract 14 from both sides, and X equals 11. So we need to bike 11 miles on Friday.